before the video starts, I would just like to mention that I do have a website. You can access it by clicking on the link in the description below. It's just ivanhong1.webnode.co.uk. I'll put it up on screen as well, but it's just a quick message to tell you guys that you can purchase my full videos in the full videos tab. It's £5 for all the unlisted videos that I'll be producing, which is the full version, which provides you with all the content that you'll need to smash your exams. So I hope this video helps, and I hope you enjoy it too. Hello, welcome to this video. I apologize in advance if I'm speaking fairly quiet. I've been recording these videos fairly late, and I'm living with a group of people, so I don't really want to disturb them. So hopefully it's still audible right now. So we're going to be going through just a quick implicit differentiation question. There's two parts to this question, as we can see. This is on the A-level math syllabus, by the way, if you didn't read the title. I'm just going to do like bits and bobs from the A-level math syllabus, just bits that I really enjoy because, as you know, or if you don't know, I'm actually doing economics and finance at university, and we use calculus quite a bit. So I'm going to be doing a lot of calculus kind of questions, especially for like A-level maths. There's not much in GCSE. It's only if you do IGCSE you'll cover the basics of integration and differentiation. If you haven't seen my basic introduction to differentiation yet, I highly recommend it. If you've never encountered it, let's say, and you're watching this video, because this is not complex, but let's say it's harder than the basics. So yeah, let's get started. So I just want to say for the first question here, it says show that dy by dx equals abx squared plus bqy all over qx plus cy is dy by dx from this equation over here. Okay, sorry for the sniffles, it's quite cold in my room. But yeah, we need to get from the top equation that's highlighted in green to the purpley blue kind of highlighted equation over here. It's like lilac now. So how are we going to get from the top one to the bottom one? Make that a bit nicer. Well, that's a good question. So there are two ways of doing this. I will show you the normal way of doing it, quote unquote, because there are actually two ways. There's the first way, which is basically just differentiate everything with respect to x, and then you get dy by dx when you differentiate anything with y, and then you factorize out dy by dx, and then you get your answer. So you can do it that way, or there's another way which uses partial differentiation, which isn't actually covered at A-level maths, but it's so much easier. So I'll show you both ways, but let's start off with the first method. So the video cut out for some reason, however, let's get back into it. So using the first method, we have p
x cubed plus qxy plus 3y squared equals 26.
right? So we'll just differentiate every term individually. So for the first bit, we've got 3px squared. And by the way, for this video, I won't be going through like every single step on how to get every single term differentiated, because when you're differentiating implicitly, you should already know the chain rule, the power rule, product rule, and quotient rule. So if you don't know those, go back and watch some of those videos before you go into implicit differentiation, because implicit differentiation uses all those techniques to combine, trying to differentiate basically multivariables. It's multivariables because it's more than one. So here we have x and y, which is why it's called multivariable. Nothing scary. But yeah, I'm just saying, if you don't know how to do those, then go back and watch those, and then come back and watch this. So moving on, we have
qxy, so obviously here we just product rule. We've got qx dy by dx plus qy, and then for the third term over here we have plus 6y dy by dx. And this obviously equals to 0 because there's no x and y over here.
So now we've got this. It's like, whoa, Jesus Christ, in your face. So just one more time before we simplify anything else. we got this bit from the first term, so I'll just highlight that. And we got the second term from this, all of this, right? Because of the product rule, we use U and V. And then for the third term, we got this. Okay, so now let's factorize. So we see that blue and pink have a common factor of dy by dx. So we'll just do 3px squared, then plus dy by dx. We can take out a factor of dy by dx because both terms have it. Well, this term and this term have it, so we can just do it with these two. So open brackets qx plus 6y, and then obviously you got to remember that qy doesn't have a dy by dx, so you got to put it outside of brackets. So it's plus qy equals 0. Now this is kind of starting to look like the this one over here, this form over here, right? And you can kind of see it coming. So all you need to do is basically put it in that form and then give the question the answers. So we have this term here and this term here, which we can move on to the other side. So we'll just have dy by dx equals, oh, sorry, dy by dx is qx plus 6y, which equals minus 3px squared minus qy. Okay, because it becomes negative because you subtract minus 3px squared and minus qy from both sides, which is why it's negative, because it cancels out these ones. And you bring it to this side over here. And then to get dy by dx by itself, you just divide by this value. So then it becomes dy by dx equals minus 3px squared minus qy all over qx plus 6y. I simply just brought this down here and you just get a fraction. So there's your final answer. And the question says where a and b and c are integers to be found. So these are integers, remembering that integers are whole numbers, or that's what integers means. So we have here that a equals -3, b equals -1, and c equals 6. And we can get those values because I'll highlight it on here. So we have a -3, right? B, just there's nothing in front of the q, so it's just a -1. So that's the B. And then C is the +6. So it's the C there. That's how we got those answers. Just make that a little bit more clear. Okay, so that is the first method of doing differentiation. Let me move this so then you can see this is method 1. Method 1. Okay, this is the A-level way. If you want to just remember this because it's just using chain rule, product rule, quotient rule, whatever the question throws at you, then that's all right. You're done there. You can do this way. This method is perfectly valid. It's perfectly fine. It doesn't matter at this stage of your mathematical career, as we could say. However, there is a second method, which is not taught at A level, but could be taught at A level. Okay, so for the second method, this is method 2, once again, not taught at A level, but could be taught at A level. But anyways, I'll give a little mini briefer on how to partially differentiate. It's not as hard as you think. It's just the name seems fairly complicated, and there's one extra rule you have to remember for this method, but I'll just explain what partial differentiation is. So partial differentiation, just write out really quickly. Okay, partial differentiation. So what this is basically kind of like implicit. You only differentiate with respect to the letter that you want to differentiate with. So, for the notation of partial differentiation, so typically normal differentiation is like dy by dx, which obviously means um, differentiate the function y with respect to x, okay? But when you partially differentiate, you use partial y by partial x. This kind of looks like a delta sign. It basically is a delta sign, but it means totally different things. It literally just means partially differentiate the function y with respect to partially x, or with respect to only x. So you can also write this notation. So this would be identical to f of x, right? This is a subscript, if I'm not wrong. So it's like a to the power or something, but it's like below. So this isn't, this is, ooh, this is totally different from f of x. These are two different things, right? This over here is a function. This over here means partially differentiate with respect to x. Two different meanings, remember that. Okay, so for just easier reference, I will be personally using this notation. However, you can use this notation as well. So just to be clear, f of x means partially differentiate with respect to x. F of y simply just means partially differentiate with respect to y. Okay, now we've got that out of the way, we can come back to this equation over here. So, like I said earlier, there is one more equation or formula you have to remember in order to partially differentiate or implicitly differentiate using partial differentiation. So, that equation is dy by dx, because you are still obviously trying to differentiate the function y, or whatever the function name is, g, m, t, whatever you want it to be, with respect to x, which is y, it's still dy by dx, because you're still ending up differentiating both x and y in this equation, but you're doing them separately, right? So that's why it's dy by dx. So that will equal to negative, right, f of x over f of y. This simply means the partial derivative of x over the partial derivative of y, and then times it by -1, which is why there's a minus sign here. Okay? This is the general rule. This doesn't change. This is the only rule you have to remember really hard. So now we've got that out of the way, we can make this smaller and just put this in the corner for reference. This may look a little bit sticky at first, just in terms of like how everything's mumbled jumbled, but you'll see how we will gradually get to this. It'll just be slightly more confusing at first. So let's get started with it. Okay, let me just make this smaller. There we go. Okay, so we'll start with f of x. So that equals, so do everything one by one again. I'll put up the question again. So it's px cubed plus qxy plus 3y squared equals 26. Now 26 here just cancels out in both cases because it doesn't have x or y in it like before, so same as before. So we'll start with f of x. So we have px cubed, right? To differentiate that, it's just 3px squared, because there's only x here, it doesn't matter, you just differentiate normally. Now with this one, you just do plus qy, right? Because qxy, if you're differentiating this with respect to x, qx is just 1, and then the y's multiplied by this, so you just leave it together. You basically ignore that the y is there because you treat it as if it's a constant. And when I mean a constant, I mean like as if it's a number, like 10, 12, 15, which is why it just stays there and it doesn't change, because it's a constant. Remember that. And then the 3y squared, it has no x in it, so you're just flipping out, ignore it. Just flip out and ignore it. That's what I meant to say. Okay, so that's your f of x. You might start to see how how this is significantly easier. But anyways, let's do f of y, which then equals, so for the first one, it's 0 because you don't have any y in the term. For the second one, again, because you're doing it with respect to y, the answer is just qx, because x in the circumstance of partially differentiating with y is a constant, which means it's just a value that we ignore. Okay? So now that's out of the way, we can differentiate this normally. So it'd be plus 6y. Then the 26 just goes away because it has no x and y in it. So we've differentiated these two things. We have our f of x and f of y. Now all we simply do is plug these two terms into the equation and you'll get your answer. So dy by dx equals, remembering that there's a minus sign at the front, we do minus f of x, which we know is 3px squared plus qy, all over f of y, which is qx plus 6y. Now, we can further simplify this. Say dy by dx equals negative 3px squared minus qy all over qx plus 6y. Now, the reason why I've made these two negatives is because I just made it so it's minus 1 times all of this. And when that happens, you get the negatives on the top, because this is the same as minus 1 over 1 multiplied by 3px squared plus qy all over qx plus 6y, which is how I got my final answer here. Because the denominator is only just a positive 1, that's why it doesn't change. So as you can see here, we get the exact same answers we got before. These two are both the final answers. Two different approaches, but get the same final result, which is perfect, which is what we want. However, I personally think that the partial differentiation method is simply easier, just because you only have to find two things and then sub it into a general formula, which is over here, and you get your answer. So those are the two methods. I'll place them down over here. If you just want to like screenshot them or something, you can. So I'll just put method 2 over here. Okay, so we have our method 1, which is the A level, and then I'll put non-A level, right? So those are your two ways. You can do it either way, both ways work. I just personally find that method 2 works better for me. However, do check with your exam board or your teacher or your syllabus, your spec, if you can use method 2, because sometimes they want you to specifically use implicit differentiation in the question. If it explicitly says in the question, like, show that dy by dx using implicit differentiation, then you'll have to use this method on the right, or on the left, sorry, this method over here, because this is implicit differentiation and this is partial differentiation. So there's a difference between them, but it's very subtle, but you just got to be careful. However, I would recommend just sticking to this, but just take note if you want to like double check or something, then there is another method here which is significantly easier in my opinion, but it's honestly up to you. So that's the first part of the question complete.